Imagine a world without the internet, a world where information isn't at your fingertips and communication is limited to face-to-face interactions or phone calls. No Google searches, no streaming your favorite shows, no connecting with friends across the globe. The convenience and instant access we take for granted would be non-existent. This was reality not too long ago. The internet, as we know it, is a relatively recent development in human history. The internet, at its core, is a vast network of computers all talking to each other. It's a complex web of connections that allows us to share information and resources seamlessly. And guess what? The internet is just one example of a computer network. There are many types of networks, each serving different purposes. So what exactly is a computer network? It's more than just a bunch of connected devices. In simple terms, it's like a digital neighborhood. Each device is like a house, and the network is the street connecting them. Instead of houses, we have computers, smartphones, printers, and all sorts of devices. These devices communicate with each other, sharing data and resources. These devices are connected together like houses on a street, and they can share information and resources. This connectivity is what makes modern life so convenient. Think of it like this. You wouldn't need to go to a library to print a document if your computer at home could talk directly to your printer, right? This is the power of networks. Networks have revolutionized the way we live, work and play. They enable us to be more productive and stay connected no matter where we are. From sending emails to sharing files to video conferencing, almost everything we do online relies on networks. They are the backbone of our digital lives. Understanding the basics of how these networks work can seem daunting, but it's like learning a new language. Once you grasp the fundamentals, a whole new world opens up. With this knowledge, you can better appreciate the technology that powers our daily lives. Now that we know what a computer network is, let's peek under the hood and see how it actually works. A computer network is like a complex web of connections. Imagine you want to send a message to a friend across the world. You wouldn't write a letter and send it by carrier pigeon, would you? That would take ages. Instead, you'd send a text message or an email that zips through the internet in seconds. This is the magic of modern networks. Computer networks function in a similar way. They are designed to make communication fast and reliable. Each device on the network is like a house with a unique address. This address, called an IP address, is a series of numbers that identifies the device. It's like a digital fingerprint. When you send data over a network, it's broken down into small packets, like putting your message in envelopes. These packets are then sent out to their destination. Each packet has the sender's address and the recipient's address, ensuring it reaches the right destination. This process is both intricate and fascinating. But how do these packets find their way through the vast network? That's where protocols come in. Protocols are essential for guiding data. Think of protocols as the rules of the road. They ensure that data travels smoothly and efficiently. They dictate how data is formatted, addressed, transmitted, and received, making sure everything is in order, ensuring smooth and efficient communication between devices. Without these protocols, our digital world would be chaotic and unreliable. Just like neighborhoods come in different shapes and sizes, so do computer networks. Each type of network serves a unique purpose and fits different needs, much like how various neighborhoods cater to different lifestyles. The most common types you'll encounter are LANs, WANs, and cloud networks. Each of these networks has its own characteristics and uses, making them suitable for different scenarios. LAN stands for Local Area Network. It's a network that connects devices within a limited area, such as a single building or a group of adjacent buildings. Imagine the Wi-Fi in your home connecting your laptop, smartphone, and smart TV. That's a LAN. It's perfect for small spaces where you need to connect multiple devices. It covers a small area, like a home, office, or school, and allows devices to share resources like printers and internet access. This makes it ideal for environments where resource sharing is essential. WAN stands for Wide Area Network, which is designed to cover a much larger geographical area. It's like connecting all the neighborhoods in a city or even multiple cities together. WANs are essential for organizations that operate in different locations. WANs cover a large geographical area, even spanning continents. They enable long-distance communication and data sharing. The internet itself is a giant WAN connecting millions of networks worldwide. It's the backbone of global communication. Businesses often use WANs to connect offices in different locations, ensuring seamless communication and data transfer across their branches. Now imagine a giant data center filled with powerful computers storing tons of information. That's the cloud. It's a network of servers that provide various services over the internet. Cloud networks are hosted by companies like Google and Amazon, offering scalable and flexible solutions for data storage and computing. They offer services like online storage, software applications, and even computing power over the internet. This allows users to access and manage their data from anywhere in the world. Learning about networks can feel like learning a new language with its own set of technical terms. But don't worry, we'll break down some key terms to help you navigate this digital world. You already know about IP addresses, the unique identifiers for devices on a network. But have you heard of DNS, the domain name system? Imagine trying to remember the IP address of every website you visit. That's where DNS comes in. It acts like a phone book for the internet, translating easy-to-remember domain names like google.com into their corresponding IP addresses. Another important term is firewall. Just like a real firewall protects a building from fire, a network firewall acts as a security guard. It controls incoming and outgoing network traffic, blocking any unauthorized access or malicious activity. Section 5. Mapping the network, understanding topologies. Have you ever looked at a map of a city's subway system? It shows how different stations are connected, forming a network of routes. Similarly, network topology refers to how devices are arranged and connected within a network. One common topology is the star topology, where all devices are connected to a central hub, like a star's points connecting to its center. Another is the bus topology, where all devices share a single communication line, like passengers on a bus route. Each topology has its own advantages and disadvantages in terms of cost, efficiency, and fault tolerance. Understanding network topologies helps network administrators design and implement efficient and reliable networks that meet the specific needs of their users. Section 6. The OSI model, unpacking data communication. Sending data over a network is like sending a package across the world. It needs to be properly packaged, addressed, transported, and delivered to the right recipient. The OSI model, or Open Systems Interconnection Model, provides a framework for understanding how data communication occurs in networks. Think of the OSI model as a 7-layer cake, with each layer representing a different stage of the communication process. At the bottom layer, we have the physical layer, dealing with the physical transmission of data over cables or wireless signals. As we move up the layers, each layer performs specific functions, from error detection and correction to data encryption and application-level communication. While you don't need to memorize all 7 layers, understanding the basic concept of the OSI model can help you troubleshoot network problems and appreciate the complexity of data communication. Section 7. Rules of the road, essential network protocols. Imagine driving on a road with no traffic rules. Chaos. Network protocols are like the rules of the road for data transmission, ensuring smooth and orderly communication between devices. One of the most important protocols is TCP/IP, the foundation of the Internet. TCP is responsible for breaking down data into packets, ensuring reliable delivery and reassembling them at the destination. IP handles the addressing part, ensuring each packet has the correct source and destination IP addresses. Other essential protocols include HTTP for web browsing, SMTP for email, and FTP for file transfer. Each protocol has its own set of rules and formats, allowing different applications to communicate seamlessly over the network. Section 8. Cybersecurity, safeguarding the digital realm. With great connectivity comes great responsibility. As we rely more and more on networks, it's crucial to protect our data and systems from cyber threats. Cybersecurity involves a range of measures to safeguard our digital assets. Firewalls, as we learned earlier, act as the first line of defense, controlling network traffic and blocking unauthorized access. Encryption is like putting your data in a secret code, making it unreadable to unauthorized individuals. Intrusion detection systems act like security cameras, monitoring network activity for suspicious behavior and alerting administrators to potential threats. Practicing good cyber hygiene, such as using strong passwords, being cautious about phishing scams, and keeping software up to date is also essential for maintaining a secure network. Section 9, the power of connection, benefits of networks. From instant communication to seamless collaboration to access to a wealth of information, networks have transformed the way we live, work, and interact with the world. They have broken down geographical barriers, fostered innovation, and created countless opportunities for businesses and individuals alike. Networks enable us to share resources efficiently, access information from anywhere, and connect with people across the globe. They have revolutionized industries from healthcare to finance to education and continue to shape our world in profound ways. As technology advances, we can expect networks to become even more pervasive and sophisticated, connecting us in ways we can only imagine. Understanding the basics of computer networking empowers us to navigate this ever-evolving digital landscape and harness the power of connection.